Hello, everyone. Thank you for joining us all, and thank you for taking some time out to learn about obsolescence risk forecasting. I'm Shaivari Barate. I'm the senior BD at iLenSys. Today's webinar is on obsolescence risk forecasting for electromechanical components. And our host for today are Manoharan, our CEO at iLenSys, and Vikram Pola, Project Manager for Obsolescence Technologies. We are going to open up for questions by the end of the session so that you have plenty of time to ask all your questions and which will be answered by Mano and Vikram. As you think of the questions throughout the webinar, you can go ahead and type them in the chat box and we will answer them in the Q&A session. Just one last thing before I hand it over. Um, we will be recording this session and the recording will be shared along with the PDF copy of the slides once the webinar is over. We will give it another 1 minute as some more attendees are joining us, and then Mano will start with the presentation.
Thank you, Savari. Yeah, we'll wait for a minute, then we can get started. So we get started, Savari?
Yes, sure, sir.
Okay. 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 So yeah, this is about the speaker. So my name is Mano Nalasamy. I'm on the video. So CEO of iLenSys and also focusing on this obsolescence management practice. So I will be walking through a couple of slides, and then we have Vikram Pola. He is our subject matter expert and project manager for the obsolescence management practice. And he will be spending a good amount of time talking about today's topic, which is obsolescence risk management for electromechanical components. Now, Vikram, we can go to the next slide. So this is the overview and agenda for today's discussion. So we will start with a brief introduction about iLenSys, and then we will quickly jump on to the obsolescence management, in general, in terms of gaps and challenges. Then we will get into the crux of the today's webinar, which is on the risk forecasting, the obsolescence risk forecasting for electromechanical components. So in that we will talk about the categories and applications of electromechanical components, part selection guidelines, and we'll briefly touch upon the risk forecasting approach that we apply in iLenSys. And then in the last couple of slides, I'll briefly touch upon beyond electromechanical in general, what we do when it comes to the obsolescence management in our solution. And then at the end of the session, we will open it up for Q&A. Yes, Sarvari was mentioning, as and when you have questions, whatever may be the slides that we are talking, Please type your questions in the chat box, and at the end of the session, we will go all the questions, and we will try to answer. And in case if you are unable to cover all the questions, if there is a time challenge, if you are unable to cover all the questions, then we will make sure to respond back with our answers in email. Okay. Now Vikram, you can go to the next slide. So this is a brief introduction about our company. So iLenSys, we are as a vision for our company. We want to be innovative and quality service and solutions provider in to our engineering customers. So broadly, we are into engineering services and solutions. In solutions, we are focusing on currently we are focusing on two areas. One is on the environmental compliances, and the second is on the component obsolescence. So today we are focusing on the component obsolescence. In both our solutions are supported by a software product. We'll briefly touch upon that as well. And as a company, we are located in our headquarters in Hyderabad in India. And we also have office in Coimbatore, which is in the southern part of India. And also we have a sales and marketing office in Illinois in USA. In terms of people, we are 300 plus engineers company, and we are ISO 9001 2015 certified, and we are also ISO 13485 certified, which is specifically for medical domain. And you can see some of our major customers we have listed here. And at the bottom is our Hyderabad office. So this is a brief on our company, iLenSys. We can move on to the next slide. So when we get into this topic of obsolescence, we wanted to start with covering the general gaps, in general gaps in obsolescence management that we are observing based on our experience working with various customers, and also its business impacts. If you look at the gaps, many times what we come across is that the obsolescence being managed reactively, or reactive obsolescence is the only approach being used across the entire product life cycle. Okay, and it is reactive probably because of lack of streamlined process in place, no continuous monitoring mechanism, and no measurement in place, to monitor, how much cost we are spending for managing the obsolescence. So these are the major gaps that we are able to observe in general, and the business impacts because of these gaps in obsolescence area is lack of parts availability, and and that can lead to a production delay, and in worst case scenario that can lead to you are not able to deliver your product on time, and that can lead to a potential revenue loss. That is the major impact that we see with the lack of parts availability. And also, if let's say the lifetime buy is, we see that is the only approach being followed in many instances. So when we do that, it is not only the lifetime buy cost, there are hidden costs associated with that, such as the capital interest associated with your lifetime buy, and the management of your excessive inventory. And when you have excessive inventory, there are degradation tends to happen, and the sunk cost tend to involve. So there are good amount of hidden cost associated if you are applying only the lifetime buy as an approach for solving the obsolescence issues. And in general, unplanned obsolescence in general can lead to a significant cost of managing obsolescence over the period of product life cycle. So these are all the major gaps and business impacts that we could observe. And if you have any questions or comments, feel free to add your questions in the chat box. With that, we can move to the next slide, and I will invite Vikram Pola, to present the topic, which is the today's topic, the electromechanical components, how we handle electromechanical components. Vikram, please go ahead.
Right. Thank you, Mano. Thank you for the introduction, and I hope you can hear me. All right. Thank you all.
We can hear you.
Yeah. Good morning, good evening, wherever you are. Thank you for joining the call. So we are going to discuss more on the electromechanical part types in this webinar session. And please feel free to drop in your Q&A questions in the chat box, and we'll make sure that we would answer all your questions by end of the webinar sessions. All right. So see, the electromechanical is another dominant category in the industry segments. You will see various electromechanical components used across several industries and also in the several applications. So if you see here, right, so you have several industries getting used. They use the electromechanical components mainly on the laboratory equipments, industrial machineries, medical devices, measurement devices, avionics, aerospaces, automotive, and also and the defense, and also in and the military applications too. But you'll see a lot of various ranges, and it has a significant application. So these are the typical applications that are getting used from the electromechanical parts. So you see like the brake modules. So these are some of the models where you see in the automotive industry as well as in the avionics. The panel heaters, you'll find them in the industrial equipments. The DC AC motor controllers, it can range in several instruments. Dip switches, they are the common ones, which is getting used across several product lines. Similar to the linear actuators and EMI filters. So the flow level controllers and sensors, so these are the ones which you can typically find in sensitive applications and the precision instruments, like it could be in the medical or in the industrial environment. Key switches, keypads, optocouplers, opto-isolators, and then the control systems like PLCs. So they are widely present and used across several applications and various product lines. Moving on to the next slide. So I will discuss more on the typical part categories. You'll get to see more in the electromechanical category. So it starts with the audio devices. So any if you see any of your audio devices, it could be a buzzer, simple buzzer, a microphone, or a speakers. So those are the electromechanical parts. So, and you'll see the encoder decoders, hardware, the miscellaneous hardware parts where you'll mount your typical PCB applications. The IO modules, so these are widely used across medical devices and also in the automation industries. Industrial automation, where you use a lot of counters, tachometers, controllers, indicators, relays and accessories, and also the safety switches. Like also it can range from the terminal blocks, solenoids and actuators on your front doors, and timers. You'll also see the knobs and dials that are present on the instruments, motors and drives. So these are also the electromechanical parts. So it can be a typical motor driver, it can be a stepper motor, a vibration motor, or it could be an AC, DC, or a servo motor. And the switches, these are the widely used in a typical application where you'll see many automotive relays, general purpose relays, high frequency RF relays, low signal relays, read relays, relay sockets and hardware, and then you have the solid state relays too. And then moving on to the switches. So these are all the various kind of switches that you can locate in the products. So these are some of the part categories where you'll find as the electromechanical and in a given product bill of materials. Right. Moving on to my next slide, mainly on the part selection guidelines. So for any given part, so this is the minimum must meet criteria. So you have to meet the form, fit, and function, right? But the part selection can go across several circumstances, or it can go across several requirements. So it could be a new NPD launch where it's still in the production phase, or it's still in the design phase, where the design engineer would select a part, would evaluate, and then he would pass a test. It could be on a released product lines where you'll see that, okay, you already have some electromechanical parts or any given part uh, that may be going through a shortages issue, or it could be an obsolescence issue. So you may need to find a replacement. So for any such circumstances, you may need to get into the part selections, right? So today we would cover one category. It's called DC fan, and this is widely used in the thermal management applications. So let us look into the selection criteria. So if someone has to select a DC fan, so they would start going with uh, choosing a fan shape, either it has a square or circular. What is a fan frame size? So it could range from 15 to 60 The operating voltage ranges, it could have you have a various operating voltages where you can able to select one based on the applications. Input current, the rated speed, so it could range from a simple 500 rpm up to 15,000 rpm. And airflow, so this is a vital parameter where definitely you would look into the CFM values, so it could range up to the 300 CFMs. And the bearing type, so when we select a fan shape and fan frame size, even the bearing type is also significant, where it comes in different categories like ball bearing, sleeve bearing, vapor bearing, or hydro bearing. And then the number of wires, so how the fan would get connected into the application. So it could be a 2 wire 3 wire application, but again it would change from the requirements, like it could be a tachometer output, or just a simple PWM control, or it could be just a direction of rotation. And then the noise, uh, type of material, like the thermoplastic, or it has to be a ULV, UL94V. The operating temperature where the DC fan is getting used, and then the other and the most important point is on the agency approvals. So typically any of the instrument that use these DC fan for thermal management, so it has to go through this minimum criteria called UL, CE, and TUV. It again varies from the country where the product is getting used, and the applicable agency certification would apply. Right. So let us discuss more on the risk forecasting approach or model. Uh, so since we are coming from the path selection guidelines, so typically the part it has to meet your product requirement as we discussed. So if you look into the product life cycle model, so it has several stages. So starting with an introduction, growth, maturity, saturation, decline, and then phase out. So it depends on where the product is and at what level of uh, uh, stage it is. So, but again, it varies from several factors, starts with sales and up to the competitors and then the manufacturer profit. So, so if whenever you select a part, you just need to make sure that at least it would meet the minimum product requirements. So meaning it has to be available in market based on the longevity where how it is available. So if your product falls in a stage 2 category, so which means it may have it has to go through 4 phases, which means it's still in an initial stage. So meaning you may need to select a part uh, with uh, uh, with at least 8 to 10 years. So, from iLenSys standpoint, so how we are going to do this risk forecasting? So you can able to once you select a part, so how it would uh, make how it would make the product to be available for a given stage. So what we would do is we would start with identifying a product or a part category. Then we would define the product grouping. So we would define once we identify the product, we would group in into a bucket. We would also check for any hard events. So hard events like the obsolescence, last time buy, NR&D like not recommended for new designs. And also look for the alternate manufacturers within the product grouping. So in case there are any alternate manufacturers, we would flag and then we would recommend it. And then we have a proprietary algorithm where it would focus more on the life cycle and years to end of life for all the parts which are in review. And then we would finally assign a risk score based on the number of parts available within the product crew. And then we will roll up the score to a given product. So we'll make sure that it would still go into the product stage, either it is in stage 2 or stage 4. So our approach in general, mainly on the electromechanical components, we would mainly focus more on the product technology, number of active manufacturers, and the impact of any upgrades or any newer technologies available. So uh, in general, you would see you won't see much technology changes in the electromechanical category when compared with the electronics or electrical category. So So based on the model, so I'll get into I will take an example application. So since we get started on the DC axial fans that are getting used in thermal management. So based on our approach, what we would do is we would identify the DC axial fans standard suppliers. So we would group into one product group. So if you see into the list, into the table, you'll see like there are 12 prominent manufacturers. They would do they would supply the DC fans, and if you see the number of parts, typically they are available from various distributors like DigiKey, Mouser, and then we would look for any hard events on these parts. We would get into the risk score, identify who's the potential alternative manufacturer, and then we would determine a risk, stating either it's whether the risk goes into a high, medium, or low. I still have an example in my next slide. I hope that would give a good clarity on how we apply this approach. So I have the sample calculation where let's take one of the NMB technologies part, and this is the ordering part number. So when you look into the current status, so this part is actually obsolete, so meaning it is no longer available. So when you look into the life cycle stage, so in the group, it's already in the phase out phase, and then the years to end of life is 0. So where this part falls into, so when we uh, when we assign a product group, so it will fall into a technology group called DC fan, and then we would assign saying that okay, what style of fan it is and what is its spec. So it's a square fan. It has 80 25 mm as dimensions. It has a 24 volt, 2700 RPM, and then a 31.8 CFM, 28 decibels, and then it's a two ball bearing and a two wire. So when we run to see if there are any potential alternates available, so we could find four parts, at least four different manufacturers who are actually giving in the same spec. So there are two parts available within CUI. There are two from Orion, Sanyo Denki, and then Sun. So these are some of the links which would help you to look into those parts available. So since we know that there are multiple part options available for the original fan, which is no longer available, so the impact of obsolescence is actually less or minimum. Meaning, yeah, still it's an obsolete, but when you look into the product bomb or from the product availability, you still have the replacements available. So so how the iLenSys algorithm is designed. So when you take this example, we would classify this typical years to end of life as 4 to 8 years. Since we know this, you still have four different manufacturers providing a similar spec. And then you have a BOM risk score, which is low, meaning you already have the alternate manufacturers. And we are backed up by a robust process while selecting the alternate manufacturers. But however, we would recommend to some of the parts, it still has to go through a typical product application qualification process before classifying as an potential alternative. So this is a typical risk forecasting approach, mainly on the electromechanical parts. I hope you got some understanding on how we approach the electromechanical parts, its categories, the applications, and then the risk forecasting model, how we do it. So before yeah, so I'll hand off to Mano, and
Uh,
Mano will be focusing more on the iLenSys approach on the next slide.
Vikram, actually, there is one question related to this Y to end of life period. The question is, can you elaborate more on methods used to determine Y to EOL period?
Right, I will answer at the end.
Sure, 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 no problem.
Yeah,
Yeah.
thank you. I'll look into the questions. Right, Mano, over to you.
Yeah, thank you, Vikram. So I think we looked into the brief overview on that electromechanical components, how we do it, and I could see a couple of questions. We will definitely answer that. So I will take probably another 5 more minutes to quickly run through another 3 slides. So this is beyond electromechanical. In general, including all type of components, in iLenSys, what is the approach that we typically go with for managing the obsolescence. So as you can see in the middle, this is a typically 4-step process we follow, and the continuous monitoring being the central and critical part of it. And in the step 1, in the bill of material analysis, so we typically start with collecting the product bill of material, or if it is done at a PCBA board level, PCBA board bill of material, and we kind of create the unique parts list. And then from there we do the analysis for the risk, and the risk we look at in multiple ways. One is the end of life risk, NR&D or last time buy within the life cycle. Okay. Or is it active? The second category we look at is the supply chain risk, especially in the recent times. The supply chain or shortage issue is more prominent. That is the second area we look at. The third area is on the compliances, especially RoHS3 and REACH. So these are all the areas we look for the risk of any given component. And then prioritization of those risks, and coming up with drop-in replacement if it is simple drop-in replacement we can find for a quick remediation. Whereas then the next follow-up steps comes into play, where we look at the critical parts of the given bill of material. So if you take any product bill of material, include not only electronics, including electromechanical and mechanical components as well, we come up with a critical parts list. The critical parts, the way we classify critical parts, primarily based on how much of a qualification lead time it would take in case if that part gets into a challenge or risk, right? So if it is a lesser time to qualify the alternate and up and running, the criticality is relatively low. Whereas if it is going to take longer time, then it is a critical part. And the other way to look at is that part is part of your regulatory or safety related testing and certification requirements. In case if that is the case, any challenges with that part, and when you go for alternate findings, you have to address those regulatory and safety related requirements. That in a way, it is going to lead to your qualification lead time. So that's how we classify the components into critical parts. And then we move on to the next stages, which is in the second step, which is risk forecasting. Again, based on the type of components, we have the methods. We looked at the electromechanical, some samples today. Same way we look at electronics and some of the mechanical components as well. And in the same step, we also look at risk due to the software and firmware obsolescence or unavailability of the latest version and revisions and so on. So we have a separate module for managing the software and firmware obsolescence as part of our step 2. Then we go into step 3, which is looking at eventually looking at step 3 before we jump into step 4. So step 3, we look at some of the procurement leverages that we can apply to mitigate the risk. And we do a couple of steps. The critical steps are, one is coming up with the dual sourcing recommendations. And if not for all your components, we look at least the critical components, and we make sure we are able to come up with the dual sourcing if it is a single source critical components. And in some scenarios, practically, it is a critical component, and at the same time, you may end up have to manage with a single source, right? You may not have a multiple source available for that particular type of components. So in that scenario, we move on to the next step of looking at your critical components, and you have to live with the single source. Then we go into the agreements and communication plans that we have with that particular supplier. And in case if it is not managed strategically, then we suggest manage that supplier communication and relation in a strategic way, which includes some formal communication plan, and if possible make that as part of the agreement as well, such that any risk to your critical components, you have at least 12 months or 18 months timeline as part of your agreement for you to resolve that particular risk on that part. So those are the things we look at from a procurement standpoint. Then we move on to, let's say you cannot find simple drop-in replacement, and some of the procurement steps are not addressing, then you have to go into redesign. And as part of our overall approach, we help our customers with the redesign of the components, or complete respin of the entire PCBA board as well. So we have done quite a few projects for our customers to address with a redesign as the one of the resolution method for addressing obsolescence. So this is kind of our overall approach that we apply when it comes to managing the obsolescence. We can move on to the next slide. So as I mentioned in the introduction slide, the obsolescence is one of our solution areas, and we have a software product to support our overall solution of addressing the obsolescence challenges for our customer. And in software, we call it as an Atom is our product. So in Atom software, in the obsolescence module, you can import your product bill of material. You will have a dedicated, as a subscriber, as a customer, you'll have a subscription to our software product as a SaaS model. And in that, you will have a dedicated workspace or vault where you can maintain, you can import and maintain your product bill of materials. And in that, we will generate part level risk assessment and report, and also we roll up that into a product level risk report. So you can periodically look at your products and product lines and say, hey, where I stand in terms of the risk due to the obsolescence. And the software product comes with the standard reports and dashboards, but in some instances, customer require specific reporting and dashboard requirements. So we tend to customize for those customer requirements. And as I mentioned, there is a dedicated workspace for each of our customers, so we can manage. The customer can manage their product bill of material and manage their risk, obsolescence risk, using our software product. And we also have this email notification feature. Any changes or any new risk that comes as part of your bill of material, you will get an email notification as well, so that you have the alert mechanism in place. Just to highlight some of the features of our software product, we can move on to the next slide. So this is my last slide. With that, we can move on to the Q&A, addressing the Q&A session. So this is just a screenshot of our obsolescence product. And just to highlight some of the key features or key dashboard items here. So this, you can see at the top, you can see the division level or business unit level or at a company level. What is the stats on your number of components, manufacturer components, and where you stand in terms of analysis and risk and so on. And the second section talks about, though it is very small, this is the area where we kind of explain your business level end of life risk or life cycle risk. So this highlights, what is the risk coming, in the next 3 months or next 6 months or next 12 months or beyond 12 months. And this bars kind of explains, how many products, and within the product, how many components are at risk, and within the component list, how many are critical components that are at risk within 3 months and 6 months and so on. And we can further create the graphs and reports by individual product or by business unit. So you can slice and dice and you can manage your risk. So this software is, we made it very user friendly, and it is effective when it comes to managing your obsolescence risk for your products for entire division. And the more important part is, this is the the continuous monitoring. Our software tool enables you on a continuous monitoring mechanism. So assuming you are managing in Excel sheets and so on, it becomes very challenging when it comes to continuously monitoring your risk and ensuring that you are having a mitigation plan in place. So this software tool helps you in the continuous monitoring as well. So this is my last slide. With that, we will conclude our presentation, and I will hand over this to Sarvari. So Sarvari, please go ahead and moderate with the questions that you have in the chat window.
Yes, Manu. So the first question that we have is, can you elaborate more on the methods used to determine the Y2 EOL period, end of life period? So Vikram, will you be taking it?
Right. Yes, sir. Right. Yeah. I mean, as we said, so YTUL is a parameter that will talk more on the availability risk. So meaning uh, uh, how much time you have, or how much what is the time period it will be available in the market. So as per our approach, how we deal with it is, as we said, so we would be grouping them into a typical a product group. We will analyze how many manufacturers are available, and we will also see where the technology is, either it's still growing, or it's still either it's in decline phase. And then we would also have a questionnaire survey internally, where we reach out to our supplier network to make sure that we also get some indicators stating that okay, whether the part or the product group would be available in market for a certain period. And from these data points, we would come back and provide in the algorithm stating that okay, so this part or this product group may fall in a certain band. It could be a 6 years period or 4 to 8 years or more than 8 years. So that's how we address the YTUL.
Thank you for that. The next question is, what are the parameters taken into consideration to flag a part as low, medium, or high risk?
Right. So typically what we do is we would go from the obsolescence or any hard events. So we would take that as the primary factor, and then we would also look into the stocking position, uh, how much uh, how much stock or how much is available from various distributors, and we would also map to the products. So we want to also make sure that what is the inventory or what is the annual usage requirement from the production line standpoint. So we would group all these factors, and then we would make them into a low, medium, or high. So uh, if you have seen our graph, the 3 months, 6 month, 9, 12, and more than 12. So the highest group would be always at the 3 and 6 month, where you may need to address those, and then go on to the medium, and then and the low category.
Okay, thank you. The next question would be, can you please provide more information on firmware obsolescence diagnostic? And is it related to electromechanical part slash semiconductor?
Right, Mano, you would like to answer?
Yeah, I can take that question. So the software is more into any type of components, let it be your PLCs or electronics or electromechanical components, where it comes with the software, and you want to make sure that in addition to the hardware, you always have the view of what is the latest version and availability of software. So let's say you're talking about one of the PLC as an electromechanical component, and when you get into, let's say, maintenance issue, or you have to upgrade for some security or compliances related requirements, and at that point in time, if you come to know that your software is not the latest one, and there is a challenge in getting into the latest, then you may end up last minute planning, and you may lose time, and it may lead to your production stoppage, worst case I'm saying. So this software tracking and making sure that what we have in our product or our equipment, and you know and proactively addressing that. So when you get into the situation, you have the solution in place. So that is on the software. Firmware, specifically when you look at in the embedded firmware, when you the challenge that comes in when you, after releasing the product, and especially if your products are in special special equipment type of categories, where you have to go back to the field for your firmware update for many reasons, right? It could be a new compliance requirement that your firmware has to address, especially in medical domain we come across, and security reasons. There are new security features that you have to get into in your firmware. And when you try to get to that, then we see a lot of challenges, in practical, in when we interact with our customer projects. That one, your operating system, for example, is moved on with the latest version, and you are struggling that point in time in the software application standpoint, and even within the firmware programming itself. You use a lot of test benches and test scripts or test cases. And when you are trying to address that after a couple of years, and if it is not properly documented and not properly upgraded to the latest, and you are not proactively prepared, those are all the surprises you come across. and it's supposed to be 2 weeks activity of updating something. Then since you do not have the right software available, firmware support system available with you, you end up spending quite a few time, and which is not expected, right? So these are all the things as part of software module we look at it, and we proactively make sure that we have all the latest softwares available for addressing some of the practical scenarios that I have explained.
Thank you for that. The next question is supply chain quality issue part of the risk evaluation?
Yeah, I can answer that. So yeah, definitely supply chain, because shortages is always in the news from past six or more than 6 months. So quality issues, again, it depends on the way how it is available or in which position the part is. But yeah, for sure, supply chain related is always included in our risk evaluation.
Okay. The next question would be Atom is iLenSys PLM tool or only for obsolescence check?
Yeah, Mano,
I,
you'd like to answer?
yeah, I can answer that. Atom tool has at least at current stage, we have two modules or two areas that we are trying to address. One is the obsolescence, and the other area is the environmental compliance, especially ROHs and REACH requirements. So those are the two areas, and those two areas in some areas it is interlinked, and we have seen companies managing that as a two different divisions with handling by two different function group. Whereas if it is mid-sized companies, both handled by the same group and so on. But so right now, it's not a PLM tool per se. If you're comparing a typical PLM tool, this is specifically to address two areas. One is environmental compliance, and the second is the obsolescence risk.
Okay. Are there any more questions? You can raise your hand or put it in the chat box. Manu, I don't see any new questions. Okay.
Okay. And thank you for joining, and thank you for spending time with us, and providing opportunity to present our methods in electromechanical components risk forecasting. And if you have, Sharvari will share this video recording of this webinar with all the participants today. And also, if you have any questions that you wanted to, reach out to, please feel free to reply and email us. We will be very happy to address any of the questions in this topic.
Yes. Thank you so much, Manu and Vikram. And thank you all for sharing your time with us today. I will be sharing the recording and the slides with you soon. And in case anyone has missed out on asking a question, you can email us and hope to see you for the next demo that we arrange. And yeah, thank you. Thank you, Vikram. Thank you, Manu.
Thank you.
Thank you. Bye bye.
Bye.